Dear students, welcome to my channel. In this video, I am going to explain how to take the measurements from the slab reinforcement and how to enter in the Excel sheet and how to put the formulas to calculate the respective reinforcement. Mainly how to put the formulas in the Excel sheet is the main topic in this video. So don't skip this video until end, then only you will understand clearly all the formulas, otherwise you will miss the formulas. So before starting this video, whoever is not subscribed, please subscribe to my channel and press the bell icon and select all, then only you will get my new videos immediately. Come, we'll start the video. So this is the tabular column which is created for making the slab reinforcement BBS. So this is our slab reinforcement bottom mat in X direction. So I am going to take this bottom mat X direction one reinforcement, making the formulas how to create it. So you see this is the one panel. So in this grid number, this is the V grid. So from this retaining wall to this V grid, we are having the X direction slab reinforcement details. You are see this is the first panel, 10 dia at 225 center to center, and here is 10 dia 225 center to center. You see same is there, here also same, here also same, here also same. In the last panel is 10 dia at 150 mm center to center is there. So in this drawing it is the wherever this wherever this mark is given, this is the rod termination mark. Either you can cut each and every panel, the rod can be cut and placed like this. This panel rod has to go to that side and this rod panel has to come this side. So otherwise if both the panel reinforcement same dia and same spacing is there, then you can run the same reinforcement directly. So here from this panel to this panel the same dia and same spacing is there, that's why we can take the through and through rod from here to here. So then what is the distance from there to there, you have to measure. Though from this retaining wall outer to where this slab is there, from this beam outer we have to take the measurement. This measurement is around 17,625 mm is there. So it is more than 12 meter. So that's why we have to take this measurement and we have to add the lap length. So if it is more than 12 meter means one lap length will come. That lap length we can manage at the any one beam space. And what is the width of this panel? This is the width. So from this inner to this inner, this is 5100 mm. This is the total slab, 17,625 mm into 5100 mm. We are having a 10 dia at 225 mm center to center spacing is there. So this value I am going to enter in the Excel sheet and just see what are the descriptions to be entered over here. So first I will take the tabular column A. In that first I will do bottom reinforcement. This is the bottom reinforcement. If you want, you can increase this description column bit more. You can make it this bottom reinforcement one heading color, and in this bottom put serial number 1. This is the bottom X direction. Bottom X direction we are going to calculate now. For bottom X direction you can highlight one more color. So in that you have to write the description where we are going to calculate this reinforcement. We have to mention this location. Where is this location? This location is in between this retaining wall and this grid V. So in the description you can write between retaining wall and grid V. Okay, then what is the number of items? Number of items means we are going to calculate complete this area. of around 17.625 meter and 5.1 meter. So this area I have mentioned. So total this area is the one number. So number of item is 1, and length, what is the length? 17,625, and width is 5100, and the dia of bar is 10 mm. Lap coefficient, so where we are going to take this lap coefficient? This is the lap coefficient. Our podium slab means ground floor slab grade of concrete is M30. For that M30, this is our table of compression and tension zone lap coefficient. For this M30 grade, for the 10 dia, so what is the lap coefficient? Lap coefficient is 475. For the 8 mm dia, 375. For the 12 mm dia, 550. Like that, the lap coefficient has to be taken. The slab is in the tension zone, that have to take 475. This lap coefficient is 475, and clear cover for the slab is 25 mm, and the spacing, what is the spacing, is 225, and lap length. So only this much is the value we have to give to the Excel sheet. So from here onwards, all this table column will calculated automatically. For that, automatic formulas we have to enter. Just watch carefully how to enter all these formulas. So this is the lap length we are going to taken, because this length is more than 12 meter. That's why we have to take one lap over here. If it is more than 12 meter, you see in this slab, if you are going to, this is the 12 meter. If this rod also same at 10 at 225, and again 3-4 meter will get add. So then again it will get increase, and if it is crossing 24 meter, then it will be 2 length. So you see from here to here, if you take 24 meter, and here you see already it is there. This is the slab 10 at 125, 10 at 125, 10 at 125. You see this is the total completely 10 at 125 is there from that end to this end. If you measure from here to here, it is more than 40 to 50 meter length is there. Then if it is more than 40 to 50 meter in length, means the lap length will come 3 or 4 numbers. That's why we have to take up to 46 meter length of reinforcement. For that, how I will enter this formula, just listen carefully each and every thing. This I will take, this is equal to, if open bracket, this total length is there, no, this total length is greater than 12 meter, put comma, again put if open bracket, again this length is greater than 24 meter, second condition, put one more comma, again this third condition, again if this length is greater than 36 meter, 36 meter, this is third condition. We'll put one more condition, if open bracket, this length is more than 48 meter, comma, so this much is enough. This is 12 meter one length, 24 meter two length, 36 meter third length, and 48 meter is fourth length. So four length is enough for this. When it is 48, so close the bracket. When the length is 48, this lap coefficient, this lap coefficient should be 4 into this lap coefficient, 4 times of lap. When the length of the rod is more than 48 meter, then 4 times of this lap length has to be taken, comma, one more bracket open, and this is the second condition. When this rod is more than 36 meter, then 3 times of this lap length has to be taken. Then close the bracket and close the second loop also. Then again comma, again open bracket, total length is more than 24 meter, means third loop. Then 2 into this lap coefficient. Again close one more bracket and one more loop, comma, and if it is more than 12 meter, only one lap length. So open bracket, 1 into this lap coefficient, or you can directly put lap coefficient. Close bracket and one more bracket close, comma, if anything is not matched, put 0. Close the bracket. This is the, so you see the formula length is this much. Okay, the answer has came only 475 because this total length is more than 12 meter, means 17.625. To test this formula, I will enter this lap length is 24 meter 500 mm. You see, two lap length got added, and I am going to enter this more than 36 meter 500. You see, 3 lap length got added, and again I am going to enter this 48 meter 500. You see, 4 lap length got added. So this is the automatic Excel formula. So where this lap length is going beyond 12 meter or 24 meter or 36 meter, automatically this lap length will get added. So only one times only you have to prepare this formula. So rest other, so just copy paste this value and you can proceed it. So I am making undo for all these values. So my original 17625 has came. Then after calculating this, you have to take the bar length. Then bar length is equal to this total length plus this lap length. This is the bar length. Then cutting length. Then cutting length is equal to this total length of the bar is there, no? Total length of the bar minus 2 times of cover. 2 into this cover. Cover is equal to, this is the cutting length. Because that end and this end we have to leave the beam cover. Then number of bars. Number of bar is equal to, open bracket, this is the width divided by this spacing, close bracket, plus 1. You see, this is the number of bars. The number of bars came 23.61. So we need to take this number of bars either from the next round off, or we have to below round off. It is 0.5, more than 0.5 is there, then it will take it to next round up, or if it is below 0.5, it will take into the below number of. For that, what you have to do, you have to put one round formula here. So put ROUND, round, open bracket, and come to the end, put comma and 0, close bracket. You see, now it has taken round of value, it is 24 number. Next, total number of bars. Total number of bars is equal to this number of items multiplied by this number of bar. This is total number of bar. Then total length in meter. Then total length in meter is equal to cutting length multiplied by this total number of bars divided by 1000. This is the total length in meter. Next, unit weight. This unit weight is equal to this die of the bar, D into D divided by 162. This is D square divided by 162 unit weight. Then total weight. Total weight is equal to, this is total length of the bar multiplied by unit weight. This is equal to total weight in kg. Just increase this column width a bit, then this value will come. Then total weight dia-wise. Here, see here, this is the total weight dia-wise. Total weight dia-wise means here also we have to enter the if condition value. This is equal to if, open bracket, this dia means this dia of the column, this dia is equal to 8 mm. This 8 mm, why this is the column is 8 mm column, no, this 8 mm column, put comma, take this total weight, otherwise 0, then close the bracket. So this is the 8 mm. Similarly for the 10 mm, this is equal to if, open bracket, this dia is equal to 10 mm, comma, take this total weight or else 0, close the bracket. You see, here this 10 mm value came, the hash came, the increase this column width, then that value will come. Then similarly 12 mm, this is equal to if, open bracket, this dia is equal to 12 mm, comma, this total weight or else 0, close bracket. So this is the 12 mm. Similarly, we need to put for the 16 mm also. Then after entering all the if condition formula, this bottom x direction have been completed for this portion. So we have completed the bottom x direction calculation for this portion. Similarly, we have to calculate for the y direction, means we have to take this y direction drawing, go to the same location. You see the y direction details have been given. 10 at 225, 10 at 225, 10 to 25, 10 to 25, all this area 10 to 25 is given. So here also the distance will be same from here to here. This is the distance, and inner distance also same. This is 5100, but for this I will explain you. So these are all the same distance, no? So for what you have to do, in the description what you have to do, the same thing, bottom you can copy this bottom x direction, control C, then come down, just insert it, and for this you can change it as bottom y direction. This is y direction. The location is same between retaining wall and grid V, location is same. And in this case, so this is 17,625 what we have taken, no? So for better understanding, I am explaining, I am giving you one more trick of this. So where this reinforcement is placed, if it is there in the x direction, no? This rod is there in the x direction. When the rod is there in the x direction, you take this length over here. Okay, this is the thing, and other direction will be the width. And in this case, you see here the rod is there in the y direction. So then y direction will be the length. So because the length of rod we are taking in the y direction, the rod is there in the y direction. That's why we have to take this 5100. Here 5100. We should not take this 5100 plus the retaining wall thickness plus this beam thickness. We have to take this beam is 350. This retaining wall is 200. So then here what you have to write, this is equal to 5100 plus 200 plus 350. This is 5650. Next, width will become as it is 17,625. 17,625. So you see here also where column width is less, we have to increase the column width bit. Then the dia is 10 mm and lap coefficient is 475, cover is 25, and the spacing also 225. Here you see automatically when this length has came below 12 meter, this lap length has not came. Whatever the formulas I have explained for the bottom x direction, no, the same formula here automatically it will calculate. You see the y direction total quantity also came. Next, if you do further calculation, how to do, just copy paste and go. So further in the next video I will explain how to calculate all this panel reinforcements in one video. So in this video I hope you people all understood this, how to enter this formulas and all. This video main concept is how to enter these formulas and all in the Excel sheet. In the next video I will explain you for the top mat and bottom mat and everything. If anybody wants this drawing or Excel sheet, contact this number or email ID. I will share with you for your practice. Or you can comment in the comment box as a drawing with your WhatsApp number. Then I will share you the drawing. I hope you people have liked this video. Kindly like and share with your friends and colleagues. And if you have any comments, please comment in the comment box. Thank you. Thank you very much.